In this video, I'm going to demonstrate installing a sample application on our TKG workload cluster. The sample application we are going to deploy is called Spring Music, and it is going to be deployed using the images that we have stored in our hardware registry on the TKG shared services cluster. So I don't yet have an ingress controller installed on my workload cluster. So I'm going to install that as well as the prerequisite cert manager using Tanzu Mission Control. So you will see I'm logged into Tanzu Mission Control, and in order to deploy those packages, I'm going to click on clusters, and then I'm going to select our workload cluster, which is this one, TKG 160-WLD01-NSX. And once I've clicked on that, you will see a view appears showing an overview of that cluster. And you will see a number of tabs along the top. So the one we are going to use is called add-ons. And that will open a new view showing all of the packages we currently have installed on this cluster. And most of these would have been installed during deployment time. So in order to install our two new packages, I'm going to click on Browse Packages. And you will see it's automatically selected the context of our workload cluster. And the first package I'm going to install is Cert Manager. So I'm going to select that. So a new view will appear showing some details around the Cert Manager package and the version, as well as the configuration values that are defined as part of that package. So in order to install this package, I'm going to click Install Package. And you will see we can now modify the configuration of that package before we deploy it. So in order to install this package, first of all, I'm going to provide it with a name. So I'm going to call it TKG 160-WLD01-NSX-Cert Manager. I'm going to use the latest version of the package. And the only configuration option available to us is to change the namespace that this package is deployed in. I'm going to leave this as default, so it is going to install into the cert-manager namespace, and I'm then going to click Install Package. So you'll see it will return back to our Tanzu Packages view, and we can see that our newly deployed package is currently listing as reconciling. So this might take a few minutes to install. I'm just going to click refresh until it lists as succeeded. So there we go. Our package is listed as succeeded. So Cert Manager should be successfully installed on our workload cluster. And so the next package we're going to install is Contour. So in order to do that, again, I'm going to click Browse Packages. You'll see the context is still set to our workload cluster, and then I'm going to select Contour by clicking on the Contour option, and the view will be displayed again showing some information about the package, the version and the configuration options available. So in order to install this package, I'm going to click Install Package, and again we're going to provide a package name. So in this case, I'm going to call it TKG 160-WLD01-NSX-Contour. For the package version, I'm going to leave it as the latest package. And you will see that there are a lot more configuration options available as part of this package than there were for the Cert Manager package. Most of these values we're going to leave as default. The only value we're going to change is to change the service type for Envoy to type load balancer. So I'm just going to click this pencil icon to change the setting for that. And I'm going to enter load balancer in the new box that appears. So once we've entered that, I'm just going to click confirm, and you will see that the value is now defined as part of this configuration option. So Envoy, service, and type. So what this configuration means is that when Envoy is installed, it's going to create an Envoy service. And because we are setting that to type load balancer, it's going to get a publicly available IP address from NSX Advanced Load Balancer on the cluster VIP network. So we should be able to access any ingress configuration defined in Contour. So now that we're happy with the configuration, I'm just going to click Install Package again. And you'll see again our package is listed here in the Tanzu Packages view, and it's listing as reconciling. So I'm just going to wait for that to complete. And so you will now see that the Contour package is listing as succeeded. So it looks like it's installed correctly. So that's our 2 packages installed in order to enable ingress control. So I'm now going to switch over to my Bootstrap machine in order to validate these packages and also to install our sample application. So over on my Bootstrap machine, I'm just going to issue a few commands in order to validate that our packages were indeed installed. So first of all, I'm just going to check that my context is currently set to the workload cluster. So to validate that, I'm just going to run kubectl config and then current context. And you will see that our current context is set to the workload cluster. So the second thing I'm going to do is I'm going to check that our pods were created for the 2 packages that we deployed. So I'm just going to run a kubectl get pods for all namespaces. And you will see 3 pods created for our cert manager package, and those have been created in the cert-manager namespace, and it looks like those are all running correctly. And then for our second package, you will see that a namespace has been created called Tanzu-system-ingress, and you'll see our 5 pods created there for our Contour package, and it looks like those are all running as well. So everything looks like it's deployed correctly. So the last thing I'm going to do is I'm just going to run a kubectl get service across all namespaces, and we should have an envoy service here, and there it is. You can see it's been created in the Tanzu-system-ingress namespace, and it's of type load balancer because that's what we defined in our package configuration. And you will see it's been assigned an external IP of 172.19.75.10. And that is a IP that's been allocated by the NSX Advanced Load Balancer on the cluster VIP network. So you will see I'm currently in a directory called spring-music-kates-deploy, and this is just a clone of a publicly available Git repo. So I'm going to do a listing of the files in there, and you will see there's a number of YAML files which are essentially Kubernetes manifests that are used to deploy this application. But you will also see a customization file. So this can be used to deploy our entire application and also customize some of the values in the manifests themselves. So the first thing I'm going to do is I'm just going to edit the ingress manifest, and we just need to modify here the FQDN that we're going to use to access this application. So in my case, I'm using nip.io, and I have a natted IP address which is natting to the external IP that was allocated to our Envoy service. So in my case, this is not 26, it is 27. So I'm just going to change that. And we don't need to change anything else in this configuration file. So once our application's been deployed, we should be able to access it in a browser using this FQDN. So I'm just going to save this file. And now I'm going to make some modifications to the customization file. So I'm just going to open that, and you will see 2 primary values included in this file. So the first is namespace. So in our sample application manifests, we haven't actually defined any namespace for the objects to be deployed into. So by including namespace in this customization file and deploying using this file, it will automatically add a namespace to all our manifests. So our sample application will actually get deployed to a new namespace called spring-music. The second thing you'll see here is a resources entry, and this essentially tells Customize all the manifests that we want it to process. So currently we have our 3 manifests, which you saw from our directory listing, included here. Now we're going to add another bit of configuration here, and this is essentially to replace the referenced images in our manifests. So our manifests at the moment are referencing public container images, and we want it to be modified to reference our internal Harbor repo and pull the images using that. So you'll see I've added 2 entries for the images that the sample application currently has defined, and I'm replacing them with references to our internal Harbor repo images. So those are all the changes I'm going to make to the customization file. So I'm just going to save this, and then I'm going to run a clear. So we can validate the changes and review how Customize will now generate the new manifests before we apply them. So in order to do that, I'm going to run a kubectl Customize and the current directory location, and this will print out the newly generated manifests that we can use to deploy the application. So let's have a look through here. So the first thing you'll notice is that all of our objects now have a defined namespace as part of their metadata. So they will all be deployed to the spring-music namespace. So you'll see it here for this service, and you'll see it here for this service, and you'll see it here for the deployment. So it's added it to all of our objects that are getting created. The second thing you'll notice is it's consolidated our 3 manifests into a single manifest. And the third thing you'll notice is if you look at the image that's being referenced, it has been replaced with the internal Harbor registry image reference. So this is what we defined for Spring Music container, and this is the one we defined for the MySQL container. So before we deploy our sample application using our newly generated manifest, I'm just going to create the namespace that we defined for those objects to be created, because it doesn't exist as yet, and Customize doesn't create that by default. So I'm just going to run a kubectl create namespace spring-music, and we'll see that namespace has been created, and then I can apply our newly generated manifest by running kubectl apply -k and the current directory. And there you will see all of our objects for our sample application look to have been created. So I'm just going to run a kubectl get pods, or actually I'll run a get all on that namespace, so spring-music. And you'll see that we have our 2 pods that are either running or still creating. We have our 2 services, our deployment for the Spring Music front end, and a stateful set for the MySQL database backend. So I'm just going to check that again, and you will see that everything is now running. So it looks like we have successfully deployed our sample application utilizing the container images stored in our internal Harbor registry. So I'm just going to validate that by running a kubectl describe on one of the pods. So I'm going to choose this Spring Music pod under namespace spring-music, spring-music. So it looks like I've entered a pod twice there. So I'm just going to remove one of those. And looking at the messages here, we can see that it's successfully pulled the image from our internal Harbor repo. So that's the behavior that we expect. So we should be able to access our application now on that FQDN that we defined. So I'm just going to switch over to a browser window. So over on our browser window, I've typed the FQDN into the address bar, and it looks like our application is running and is available. So to test its functioning correctly with its back-end database server, I'm just going to delete a couple of these albums. So I've deleted 3 albums there, I think, and then I'm just going to run a reload, and you'll see that the state has been maintained. So one other thing we can validate is to check whether the Harbor registry has recorded any pull requests. So I'm just going to switch over to the Harbor UI. So over on the Harbor UI, I'm just going to log in using the admin account. And then I'm just going to navigate to our base project, and you will see that we have some pulls registered here. So Harbor has recorded that a pull has occurred against these images within the repository. So that brings us to the end of this video, where we demonstrated successfully deploying our sample application with images pulled from our internal Harbor repo. I hope you enjoyed this video, and thank you for watching.